It's the intersection of big data, data security, and data privacy. And
anyone today who is doing massive amounts of data and analytics is aware of the fact that I now have to make sure that I protect that data.
The problem is complex to solve, and we know it requires everybody in the organization across all functions and work on it together.
How do you navigate that within a company? It's an important conversation.
Try it again. Welcome, everyone. Great. You passed your test. You managed to navigate your way here through the MIT labyrinth. Very privileged to have with us today Justin Nguyen, who's Senior Head of Data Engineering and Analytics at Chewy. And the thing that caught me in his bio is that I'll just read it here. It's commercialized data science products and projects that have increased revenue, reduced costs, and led to greater operational efficiencies. In my experience as a consultant in this space, that's pretty rare. So I'm very eager to hear what Justin has to say. So without further ado, I'm going to hand it over to Justin. If you do have a question, raise your hand and I'll get the mic to you, okay? Great, thanks.
Great, thank you, everyone. I just ate lunch, so I'm going to sit. But it's great to be back in person. I'm from the great nation of Texas, so getting away from the summer heat is always nice. Like we said, my name is Justin, and I work for a company called Chewy. Who here has heard of Chewy? Okay, pretty much everyone. Keep your hands up if you are a pet owner. Anyone? Okay, awesome. So Chewy, terrific company. We're very young, founded in 2011, and we went public just 3 years ago, and then just very, very rapid growth. Last year we broke the Fortune 500, this year the Fortune 400, growing very fast, and we're actually recently featured as one of Newsweek's fastest growing online shops. Can't say enough good things. We've won many, many awards. These are just a few. Best place to work. A couple things not on here are recently best leadership, best career growth, best engineering teams. We even won an award for best HR team. I'll say that again. We even won an award for best HR team. So it's a little bit about Chewy. Happy to talk more about it later. Let me talk a little bit about what I do. So first, I am a full-time dad. I pull my jokes from a database, and I also have this AI hobby, and it gets a little bit wild and crazy when I mix the two. We'll get to that in a second. Let's talk about the first part, just being a first-time dad. Being a first-time dad is absolutely terrifying. It's terrifying, and you're just constantly worrying, is your baby breathing? Is she awake? Is she sleeping? You're constantly worrying, you're constantly checking, you're constantly stressed out, and you're constantly just terrified. So what do? Well, if you're at this conference, you're probably like me. You probably turn to technology to help solve your problems. And so first, you check the market for baby products. Second, you become dissatisfied with the accuracy and quality of said products. And then third, you realize what you knew all along. Nothing is good enough for a baby girl, so you got to build it yourself. So this is a computer vision program that I built to accurately monitor my baby. And first, there's an IP camera. It's basically like an outdoor security camera. It's angled and pointing at the baby. It's plugged into my router via Ethernet cable. So basically, I can access the camera feed and then pull frames by pinging my router's local IP address. I'm not opening up any external ports. So the camera feed is not available outside my Wi-Fi network. Once I pull the feed, I can sample frames basically as fast as I can process and analyze them. Now, computer vision program, it's written in Python. It leverages an open source library called OpenCV. And OpenCV basically just has a lot of useful time-saving image processing classes and methods. So program basically does three things. First thing it does is it finds the baby's face. Second, once you find the face, it looks for the eyes and then determines whether or not they're open or closed. And then the third, which is probably the easiest part, is once you can find the face, find the eyes, very, very easy and quick to triangulate the position of the cheeks, grab the RGB values, and then you can track the slightest changes in color. Too pale, too red, so forth. So anyway, that's all the analysis that happens, and of course, this all goes back to the database. Now, this is probably easier said than done, and the biggest challenge for a CV program, a computer vision program, is to learn and remember what a baby's face looks like, and how does a computer learn? Well, it's really the same way that you do, just don't necessarily realize it. So when you see a face for the first time, your brain automatically starts to process and capture the features. So features can be shapes, they can be colors, they can be boundaries, they can be edges. Now, while your brain processes all of these features, it doesn't actually remember every single one. It hones in on the ones that are distinguishing and unique and differential. Now, this is a much more efficient way and fast way to learn and remember a face. And a computer vision program is the exact same way. It's just exploded and escalated and magnified. So in computer vision, we can detect all of the features, the shapes, colors, boundaries, and edges. And then we can analyze and learn and remember those distinguishing features, and that's how we learn and remember a face. Now, the problem with computer vision, ironically, is that it's a little bit childish, and it's a bit immature when it comes to focus and not being distracted. So you can actually see that in this image. Yes, we're able to detect features on the face, but you'll also see green boxes elsewhere in this image, which basically means that our computer vision program is getting distracted, and we don't like distractions. So how do we get rid of that? You've probably noticed that a lot of your images, their file size can be very, very large, and that's because an image is basically just a three-layered array. It's an RGB matrix, and especially with camera resolution these days, these arrays are massive. So each image is hundreds of thousands of values. Now, most of these values we don't care about. It's just noise. The name of the game is to drown out as much noise as you can and focus on the signal. So we do that by processing this three-layered array, and then we just perform various matrix and vector operations. So there's thousands of ways you can do that. For example, if you wanted to get real crazy, you could just cut a third of the size off by removing one of the arrays. And you could calculate the eigenvalues of each array, cut the one with the smallest eigenvector, and that's how you would cut it by a third. Now, sounds complicated, but it's not, because remember, we're at MIT. Now, most of the edges, most of the boundaries, the features, they're going to be at the interface of a very, very large shift in values, and we call this a gradient. So with smaller gradients, you can sample down and drown out a lot of that noise, and then the larger gradients will be left behind. And that's really all this is. Once you perform all these operations, you're left with a much more simplified image and a much smaller matrix. And if you can look, basically going here from left to right, we reduce this image down, and it's very, very easy to find the face. Once you find the face, we can find the eyes and the cheeks. Likewise, when baby girl is sleeping, we do the same thing. We isolate key features. We find the face, no eyes, she's sleeping. So I can go on about the intricacies of computer vision, but there's a different reason why I bring this up. And when I'm talking to really any C-level executive or interviewing any technical contributor, these are the kinds of data science projects that everyone wants to do, right? These are high impact, these are high value. It's innovative, it's computer vision. And it was also built very, very quickly, and trust me, it was built very cheaply as well. So the question is, why is this so much easier to do at home? Prior to Chewy, I was at 7-Eleven, and prior to that, I spent many years helping private and public companies of all sizes launch or relaunch their data science projects and programs. So definitely not an easy job. This was taken from a VentureBeat survey years ago. I'm sure most of you have already seen this. Basically, the majority of data science projects, they never make it to production. Most of the data science projects that you do, most of the data science teams that you build are not destined to succeed. So that's just great, right? and why is this? Why are so few data science teams and data science projects successful? So today I wanted to share a few things that I've witnessed and share some scar tissue around some teams that I believe have really distinguished successful programs versus not so successful programs. And so three things. First is summoning the right players for your team. The second is balancing near-term use cases with long-term vision, and we'll relate that to cooking. And then the third is changing gears a little bit and talking about innovation. I'll spend the most time on this last one. But yeah, talking about innovation and really what makes innovation so difficult. All right, so let's get started with building the right team. Before we talk about the people, let's first establish what exactly are we trying to do, right? So if we want to position and draft the players, then first let's align on what we're trying to achieve. And successful data science, as we've all kind of realized by now, it takes more than just success within data science. It's more than just the data scientist. It's more than just the hyperparameter tuning and the iterative development cycles and sprints, even beyond CRISP-DM. So successful data science requires success beyond data science. And what does that mean? Well, it requires a bunch of things. It requires you to find a feasible and valuable opportunity that hasn't been tapped yet. It requires due diligence and validating some insight. It requires lots of accurate and accessible data, so forth. It requires all of these components, and these are really difficult challenges that you have to get right. And you have to be successful at every one of these toll gates, or else your project isn't going to make it. And you really can't ignore or fail at any of these and still come out successful on the other side. So again, I think by this point we realize that data science teams are more than just data scientists. And that brings us to a more kind of holistic and balanced approach. And this is one framework I've examined where, again, it just has much more balance than just a pure one-man band or purely one type of player on your team. So rather than asking your data scientists to do everything under the sun like we used to do, we're now allowing them to focus on what they're good at. And we add other people, different people with different skill sets. And this is a good thing, right? This is a step in the right direction. We're adding subject matter expertise. We're adding experience. We're adding executive engagement. We're adding executive communication as well. And when we go back and we map these to the last slide with the different processes, that's what we need. We divide and conquer, and it's much better, again, than having one person or your data scientist just trying to accomplish everything on their own. Now, you might be looking at this template, you might be thinking, wow, this is great, look at all these resources and expertise. And you're right, this has worked. It's a recipe that works, but with any recipe, you can follow a recipe and still get it wrong, still not get the output that you want. And how does that happen? Well, it happens when you don't understand the recipe. You need to understand what every step does and what every component is supposed to do, and then that's how things come together at the end. So if we were to just kind of break this apart, start with these three roles. These are all great roles and great people to have on your team. And then, based on their responsibilities or position within the company, they also have access to a lot of resources, experience, data, and other expertise. But that's still not enough. What really successful data science teams that I've seen, they have people who do more than just serve in a role. They actually have specific resources and skill sets that can deliver results. And so what does that mean? Well, these are people who can assume a role, but they also leverage some exceptional quality that they have. And the quality isn't really a job title. It's this kind of natural or seemingly effortless intrinsic talent that they're very well known for. We all have or know someone in our companies who is an exceptional storyteller, who's an exceptional innovator, who's an exceptional leader. And they're very, very hard to find. They're a pain to get a hold of, right? They don't have, they're not sitting around and waiting for you to give them the bat call and ask them to join your team. They're very in demand and they're very scarce. So it's difficult. But when you can combine these qualities and the qualities on the right with basically the resources on the left, this is what makes the recipe work. So the other two roles on here, data scientists and data engineers. There's just one thing I'm going to say about data scientists and data engineers. Chewy is hiring, so let me know if you're interested. All right, let's move on. Picking the right use case. So I want to talk about cooking, and I want to talk about cooking for a date. And I mean like a date, okay? Not someone who you're really too familiar with, but someone who's maybe a little bit new or someone you're really, really trying to impress. And so what starts going through your mind? Well, the first thing you're probably asking yourself is, what can I cook well? And then from there you go, okay, well, out of that list, what on this list is going to impress? So remember, this is a date, so first impressions, they go a very, very long way. You need an early win, and you want your early win to be a double win. So the other thing is that cooking for a date is one of those things where there's just a lot that can go wrong, right? It's one of those things in life where you have a very finite numbered paths to success and a seemingly infinite, limitless number of paths to failure. So for example, maybe you decide that, hey, I've got nothing in my arsenal that will impress, so I need to try something completely new and something you never made before. Obviously very, very risky, and your odds of success are not great. Another thing that can happen is that you aim for perfection. Maybe you start to overthink or overdo what you're making, and then as a result, it actually makes things worse. Maybe you overcook something, for example. And then last is insufficient planning. So you may forget to check the pantry for ingredients. You forgot to plan dessert. You prepared the wrong wine. The list goes on. So you get the point. The point is that there's a lot to think about, and there's a lot that can go wrong. Picking a data science use case is a lot like cooking for a date. So you start really with the same question, right? You ask yourself, hey, what can I cook well? What's feasible? What data, what technology, what resources do I have? And then you start asking, okay, well, from that list, what's going to impress? What's going to be the most valuable? Which use cases will deliver value and deliver them quickly? Now, remember that first impressions go a long way. Your early wins, they need to be double wins. And then the same pitfalls apply. So you can try something completely new and completely outside of your wheelhouse. You can try to build some crazy AI. That's pretty risky, and the odds of success are not good. Another pitfall is aiming for perfection. Data science is obviously not about perfection, right? Data science is about progression. And aiming for that perfect machine learning model that's 100% accurate 100% of the time is a great way to bankrupt yourself. So finally, insufficient planning. And this is arguably one of the most common pitfalls I see. And the success of your data science use case it's going to be determined by your planning. Planning your use cases is where companies, they often trip. Sometimes they even skip, and they don't get their value. So how do you plan? It's the same way you would plan anything else. So first determine what's highly feasible, what's art of the possible, and sometimes, oftentimes this means gathering leaders from across the organization and brainstorming these possibilities, the pain points, the nice to haves. It sounds tedious, but it's actually pretty enjoyable. it gives people kind of an opportunity to be heard and share their ideas. And people want to improve their business. So usually these discussions are actually turn out to be a lot of fun. Once you determine the art of the possible, you prioritize them by what's valuable. So basically, you rank them based off of their measurable value that they return, and then remember, your early wins, they need to be double wins. So once you have your use cases picked, I want to actually talk about a step that gets skipped, even though it makes a big difference. So this is kind of a very, very common approach, and I'm sure many of you have also seen or experienced similar. A lot of data science projects, they start with this quote, and we've all heard it before. Hey, we have all this data, what can we do with it? And so, as a result, what do we naturally do? Well, we go to work, right? We acquire the data, start analyzing, developing, and then at the end, we try to derive or summon some value that we can get out of it at the end. There's a couple of problems with this approach. First is, a lot of times you don't get a chance to finish. Your head's down working, and maybe you get close to the end, but then you get pulled off into something else. And there's always some other problem that demands a data science skill set. The second thing that often happens is confusion. So stakeholders, they'll get confused, or maybe we get confused as data scientists or data engineers on what exactly we're trying to achieve or deliver. And it's bad because confusion kills momentum. We talked earlier about evangelists and storytelling. Well, if you can't get buy-in from outside of your data science team, especially if there's confusion or just zero energy. So point being is that the likelihood of success for whatever use case that you're trying to achieve using this approach is going to be very, very slim. Now, a better approach is to spend more planning up front. So you still acquire the data, you still analyze and develop, and so forth. But before you do, you do two things. First is you identify and study the actual problem or pain point that you're trying to solve, and then you establish your KPIs up front. Like what KPIs are you trying to move? By doing a little bit more planning at the beginning, it resolves the two issues we saw earlier. So first, it protects you from the scope change. Now everyone knows what you're focusing on before anyone starts cutting any Python. And then second, it eliminates confusion by setting clear goals to march towards. So these are goals that can be communicated and shared so that everyone is aware. It's a very, very simple step, and it solves a lot of headache down the road. So after you do your due diligence and your planning, you hit the ground running and start to execute your use case. So by now, I think data science it's a little bit different than your kind of traditional slow-moving IT. For example, kind of traditional IT, it's very focused on minimizing risks, whereas data science, it's very risky, and it involves very, very heavy and rapid experimentation. So data science, you learn as you go, not before you go. And good data scientists, they'll fail fast and deliver very, very fast and rapid incremental wins. A lot of the do's and the don'ts on here, they go back to a lot of the things we talked about earlier. Don't aim for perfection, aim for progression. Make sure you're focused on delivering value, and focus on what will impress your business or your customers. All right. So let's talk about innovation. Innovation is it tickles me a little bit because there's just so much noise and hot air with it. People spend months and years talking about innovation. They'll come up with a dozen committees or methodologies or workshops or frameworks, and then in the end, they don't have anything to show. And just quite honestly, the vast majority of companies are just not good at innovation. But there are a few that are. So this is an article and a quote from 3 years ago. There was this interview on CNBC with Katrina Lake, who was the CEO of Stitch Fix at the time. And basically their stock skyrocketed overnight. They had just reported earnings, and if you listen to the interview, Katrina Lake, she basically attributes this wild success to their algorithms and data science team. A few months shortly afterward, Eric Colson came out with this quote, and it's basically one of the best things anyone's said in a while. So he said, at Stitch Fix, we have more than 100 data scientists who have created several dozens of algorithmic capabilities, generating hundreds of millions of dollars in benefits. Yet virtually none of these capabilities were asked for, not by execs, PMs, or domain experts, not even by a data science manager. Instead, they were born out of curiosity and extracurricular tinkering by data scientists. Now, we all know curiosity and extracurricular tinkering is basically just a euphemism for messing around. So basically, he has over 100 data scientists. They're just messing around. No one's telling them what to do. And they generated hundreds of millions of dollars worth of value. Great story, and certainly, a great place to be with innovation. But again, there's only so few companies who actually achieve this. And why is that? Well, it's because of the nature of innovation itself. So at its start, innovation is very ugly. And those are not my words. Those are the words from Sir Francis Bacon 500 years ago. And if you read this quote, he's basically calling innovation an ugly baby. Right? That's why innovation is hard, because at its start, you don't recognize it in its infancy. Here's the thing. Innovation was ugly 500 years ago, and innovation is still an ugly baby today. So this is a much more recent quote from Ed Catmull, who won the Turing Award a few years ago. And as you all know, Turing Award is the highest achievement you can achieve in computer science. I'm going to read this quote out loud. Originality is fragile, and in its first moments, it's often far from pretty. They are not beautiful miniature versions of the adults they grow up to be. They are truly ugly, awkward, and unformed, vulnerable, and incomplete. They need nurturing in the form of time and patience in order to grow. So again, just and you're probably saying, I get it. Innovation is an ugly baby, but how do I evolve it? How do I get it to stop being an ugly baby? And let me rephrase the question. How do you evolve innovation in a way where you can be successful while also working under all of the business pressures and forces that we're always under, right? Things like tight timelines, tight schedules, and tight budgets. And then also you need to innovate something with a high rate of return. And don't get me wrong, our field is definitely difficult. Data is a hard space to be in. But a much, much harder industry to innovate in is the film industry. If you think about it, movies, tight deadlines, tight schedules, check. Tight budgets, check. Do you need a high rate of return? Definitely. It's all the same challenges that we face, all the same forces. And quite honestly, most films are not good, right? They're not innovative. A lot of films, even now, are still remakes of remakes. Now, innovation and originality, it's scarce, and no studio is able to consistently achieve success in innovation except for one. Ed Catmull, he also co-founded a company that produced over 14 box office hits in a row, over 14 critically acclaimed films in a row, and in addition, the studio is producing original films, not remakes or film adaptations. That company that Ed Catmull founded was Pixar. So in November of 1995, Pixar had an incredible week. On November 22nd, they released their first film. It was a movie called Toy Story, and it turned out to be instant classic, still holds 100% on Rotten Tomatoes, and one of the highest grossing films of that year. And then a week later, Pixar went public. It was the largest IPO of that year, and the stock price doubled on the first day. Here's the best part. No one had heard of Pixar before. In fact, prior to Toy Story, Pixar did not have much success. Pixar had been around for over 20 years before Toy Story. They just weren't making films. They were a computer graphics company, and they were struggling. You can see here that they were never really able to take off and gain that momentum. And actually, as a matter of fact, in the 90s, in the early 90s, they started to fall apart, and Steve Jobs, who was the majority owner at the time, he was actually trying to sell the company less than a year before Toy Story came out. So what happened? How did they go from this failing company to this wildly innovative and successful film studio so quickly? So not only that, but they did that in an industry that has very tight timeline schedules, budgets, and demands a very high rate of return. So Ed Catmull, he turned Pixar around very quickly, and he did two things. First, he addressed Pixar's blind spot, and so Pixar was a computer graphics company. They had this great innovation, but it wasn't necessarily a great application, and there wasn't a very clearly defined purpose for what their innovation could do. So he had a team of very, very sharp people, but they weren't great storytellers. So he decided to partner with arguably the greatest storytellers of our time, Disney. So when you can combine Disney storytelling with Pixar's graphics, now you created a movie experience that no one had ever seen before. The second thing that Ed Catmull did, he created something called the Braintrust, and the name is a name, but basically the Braintrust, their responsibility was to develop the movie storyline, the characters, and the plot. So very, very, very critical components, and really much of the reason why Pixar movies are so unique and so special. Now, the Braintrust, it was an internal and it was a protected think tank to develop and nurture those fragile and incomplete and vulnerable innovations that he mentioned in his quote earlier. What was special about the Braintrust is that it was only writers and directors. So basically it was a peer-focused and peer-driven group. Most of the big decisions in the film industry are executive-driven. And most of the innovation in corporations are also executive-driven. So we saw this from Eric Colson's quote earlier as well with Stitch Fix. Basically, that at Stitch Fix, innovation is peer-driven. At Pixar, it's also peer-driven. Here's a link to one of my favorite articles written by Ed Catmull. And he talks about the Braintrust and basically how it functions. If you're interested in learning more, it's about a 10-minute read. And there's two quotes on here that I'd like to share. First, he says, put smart and passionate people in a room together, charge them with identifying and solving problems, encourage them to be candid. The Braintrust is not foolproof, but when we get it right, the results are phenomenal. And the second thing he says is every creative person can draft and service those around them who exhibit the right mixture of intelligence, insight, and grace. Here are the qualifications. People you choose must make you smarter and put lots of solutions on the table in a short amount of time. So peer-driven innovation is an interesting concept, but it's also it also sounds a little bit risky. Not only do you need the right people, but you also need to cultivate the right conditions. There's an author, a speechwriter, and I think he was an ex-lawyer. His name was Daniel Pink, and he studied a bunch of technical teams. Maybe some of you have heard of him. He came out with this theory, and I think it works really well for not just data scientists, but really all data practitioners. It's this theory that high-achieving individuals, they are driven to pursue three things: mastery of the craft, autonomy of their work, and purpose in their achievements. So I'll start with mastery. It's pretty straightforward. No one wants to suck, right? Everyone wants to be good at what they do. Everyone wants to achieve, at least some degree of mastery. Easier said than done. How do you cultivate this? Well, one powerful technique, and we saw this with Stitch Fix and with Pixar, is that they instill an expert leader. And expert leader, you can Google it, but to quickly summarize, expert leaders are basically, they're exceptionally rare because really they're three people. They're deep technical experts in their field. They also have applied industry and business experience and acumen. And then they have all the servant leadership and charisma and emotional intelligence that's required to be a leader as well. The second item on here is autonomy, and this is really about ownership. So one thing I like to tell my team is that you can have 51% of the vote, but 100% of the accountability, and meaning that you ultimately decide strategy, tactics, the how, but you also own the outcome. It becomes personal, and it's no secret that if you're completely responsible for the outcome, you're going to make sure it turns out okay. And then the last is purpose. We all want to do impactful work that makes a difference. We don't want to be wasting our lives. So if we go back again to the examples of Stitch Fix and Pixar, we see those. We see all of these themes. Both Stitch Fix and Pixar, the innovation was peer-driven, which gave them the autonomy that they needed from their executives, and also gave them mastery from their peers. In both cases of Stitch Fix and Pixar, they instilled expert leaders, so Katrina Lake and Eric Colson at Stitch Fix, and then Ed Catmull at Pixar. And then in the case of Pixar, we saw the partnership with Disney pivot and define their purpose more towards a film and a narrative-centric company. And so anyway, hopefully you can now piece together the picture. In order to kind of convert this ugly baby into successful innovation, it takes the right people and it takes the right conditions. So we talked about three things today to wrap things up. First is building the right team. Second is picking the right use cases. And then technical innovation. So some closing thoughts. First, make sure you fill the right roles on your team and understand the parts that they play. You need resources as well as skill sets, and don't just follow the recipe, but make sure you understand it as well. The second is to pick your use cases and make sure you put the appropriate due diligence into planning. It's a lot like cooking for a date. First impressions matter, so you want to deliver results quickly. And then last, give your teams mastery, autonomy, and purpose. And then once you have that established, give them more support, peer-driven innovation, and give them the resources to cover their blind spots. That is all I have. Thank you all for coming. I'll go ahead and take questions.
Awesome. Thank you so much for this. Going back to those toll gates you had, I'd be really curious in your experience where you see either like of those toll gates, like the top one or top couple where it's like you consistently see failure in data science projects.
Yeah. So I broke this apart a little bit, but really, if you were to kind of bucket and summarize this, there's really kind of three things. First is the use case, and I already talked about that. Other people at the conference have talked about that. Not going to beat a dead horse. The second is a technical solution, and then the third that doesn't get talked about as much that I think needs to more. And I don't know if it's because it's still an art or science, but it's the business adoption. And I think, part of it is, especially with adoption, that's probably the most outside of your control. There's so many other variables. And even if it's a great use case, you have the perfect solution, the timing just might not be right either. There's always other priorities. So in my opinion, it's probably the third one the most, if I had to pick, just because that's the least within your control.
Justin, I have a question. How do you get companies to give data scientists time to explore? Because we've gone into clients, and all the executives say, yes, we want data science, we want AI, but they're not willing to let them explore the data enough to get any real sense of what's there and what the value is. Do you have any sense? Because exploration, as I was glad to see you say, is very important. to the whole process?
Yeah, experimentation, especially in data science, and experimentation is definitely going to be a lot of red ink on your P&L, right? So you're going to naturally get pushback. I don't think it's an overnight thing or a single conversation or meeting that you have where you sit down with your executives and you tell them, hey, we need to give our really, really smart and expensive resources some time to discover and all of those things. But one thing that like to just couple with, kind of those long-term, long-range data science projects are certainly valuable, a lot of use and value, but there's kind of short-term, kind of quick-hit ones as well that you can iterate on and deliver like an ROI a lot faster. And it's not even just ROI on day one, but you can also express, hey, there's ROI on day one, and then on day 100, there's going to be an even greater ROI, basically meaning, hey, this is going to be an iterative kind of living project that can continue and go on. I'll give a very quick and recent example I was working on last night. So so basically it was focused around automation for really any retail or e-commerce company. You're going to have customer accounts. Those customer accounts you have to protect, and this was for basically a cybersecurity related use case. And we talk about these three things: the use case, the technical solution, and then the business adoption. Due to just kind of the nature of our business adoption, especially around cybersecurity, if you can provide any kind of automation, it's going to happen very, very fast, right? Otherwise, you're going to rely on a team of analysts, and they're all just constantly working against this massive backlog. The technical solution, honestly, was not that complicated. It was very, very simple NLP binary classification. It was based off of free-form text fields, so couldn't even use anything, deep learning, transformer architecture. It was really just, bag of words, fuzzy matching and word embeddings, really. But very, very quick. And just in that one use case alone, in 9 days, we freed up over $500,000 worth of frozen orders. So basically returned over $500,000 worth of frozen revenue back to the company. And that doesn't even include the automation. I mean, the automation was something like over 2,000 man hours that we automated. So something like that helps buy you a little bit of time so that you can do some of your more long-range data science projects.
So get a quick win, get some cover, and even the quick wins, you can keep experimenting with inside of those to expand them, right?
Right.
Thank you. Thank you, Justin. That was great, and I love the comparisons and the examples you gave. It really helps to illustrate. I do have a question on what's the relationship that you have with the business when they're making their requests for data science, right? And where I'm coming from is that sometimes I have a hard time having the business being creative enough to know what can be solved by data science. Instead, we get some people, like you gave the example, just saying, yeah, I need data science, but they don't know exactly what for, right? So how does your team work with the business to let them know what's possible and to kind of encourage them to have the great use cases that you keep mentioning, right? Because I would assume that if they come up with a need, the adoption has to be good if the technical solution is good, right? So I want your thoughts on, or explain how it happens in Chewy.
Yeah, so I'll be honest, Chewy's a little bit of an exception. I think in terms of data-driven culture, Chewy's very mature. It's almost the opposite. Like, I can't get them data fast enough. But in terms of kind of the data science use case, intake process, and prioritization, and this is just my experience, I don't think you try to standardize and make everyone funnel into one. So basically what different functions within your business, whether it's marketing, finance, supply chain, whatever, storefront, they're going to be operating at different altitudes in terms of their data literacy, their use cases, their data maturity, and really, this is probably more of a people-based approach than a process or technology-driven one. But I like to make sure that we have the right people kind of interfacing and people who can operate at various altitudes, various levels of depth, so that we can maintain and keep that alignment. And then once you have that in place, it takes time. It takes a lot of kind of just education, evangelism, what's possible, what's not possible, and then making sure, again, it's very people-centric and relies very, very heavily on scarce talent. But making sure you have someone there who can ask the right questions and look through things through the appropriate business lens as well to help drive prioritization.
We worked with a client who asked this question, and what he did is brought in an outside consultant to sit down with all the business stakeholders and ask a lot of questions and try to drive out the use cases, which we did, but we found there was, even though the executives were saying they wanted AI, there was no appetite for deploying it. It got stuck in a whole bunch of other priorities that the company had, and it didn't go anywhere, unfortunately.
Hey, thanks, Justin. That was outstanding. Congratulations on the new baby and the AI to help keep her safe, right? It was interesting, the thing that you identified, or the attributes of driven people, are exactly what you kind of identified as what data scientists want, right? So I don't know if that was on purpose. The question I had is, when you were talking about innovation and tinkering, right? I worked at a company where we had a lab, and our CEO did think we were tinkering over there and developing new things. Do you have a good example of quote tinkering at Chewy where it was supported by the business, or where you had kind of that latitude to go and discover?
Yeah, that's a great question. Not just at Chewy, but at other places I've worked. Chewy, 7-Eleven just earlier this year as well. A lot of it's going to be built on trust, to be quite honest. You get a little bit more leash, so to speak, when you're delivering results, and you can deliver kind of the early rapid wins. I think one thing that's very helpful is to be a little bit hands-on as well, in terms of, I talked about operating at depth with your stakeholders. You need to operate at depth with your team as well, right? As a leader, you're connecting dots, and so you need to understand where all the dots are, and then how they kind of connect and find these innovation opportunities. So this actually is one of the first robots I built. It's just a very, very simple printed circuit board. It's got 5 infrared sensors on it and 2 motors, and it just drives around, follows a line. And there's certainly more advanced robots out there. But just this, again, it's just a little bit of this kind of tinkering now. So all of a sudden gives you, especially with e-commerce, a lot of warehouses now are going, autonomous, leaning very, very heavily into robotics. And I think even though this was not, this was just a project that freaked out my dog, it gave me a lot of expertise to kind of start having conversations with some of our fulfillment centers about, hey, what would it take for robotics? What are some of the things we need to think about? Certainly not an expert in firmware and printed circuit boards, but showing that, hey, if there's not immediate value in terms of your P&L, at least there's value in gaining expertise and enriching kind of your workforce.
I'm going to follow up on my statement. So a lot of data science projects fall flat at deployment, right? Especially if they're trying to deploy into an operational application. So the customer I mentioned is a global manufacturer, and there are a lot of the use cases we identified were sales and marketing. They really wanted to upsell and cross-sell. This was it's kind of a conglomerate that had been formed through a lot of M&A, right? So a lot of cross-sell opportunities. So there's a lot of pressure on the CRM system, which I think was Salesforce or something like that, but getting access into that system, having Salesforce developers build the model into the system, and then getting the salespeople to actually use what was produced, because they had a lot of different other apps that they were supposed to be using. And that's a big reason why all these things fell flat, is because there's just too many other priorities, especially if it's an operational deployment. So in terms of deploying to an operational system, do you have any recommendations for how to make that happen in an efficient way?
Yeah, the business adoption is definitely the most difficult. I would say, one very, very fast way to get things adopted, and I'm speaking from a very specific example where from the ideation meeting to deployment production was a total of 72 hours, like very, very fast. Attack the priorities you mentioned, like attack the pain points. One thing I like to ask my executive C-level is, what's keeping you awake at night? And attack that, figure out a way to automate or produce value, draw KPI or ROI around it. And that's how you'll get something deployed to production very fast.
Maybe to that point, I think that probably also implies that Chewy has a good ML ops or ML framework and structure underneath it. Maybe you can speak a little bit to that and how you can go from prototyping a model to actually clicking deploy in 72 hours. So that's probably a big part of what you were able to do there.
Yeah. So a little bit of background about how Chewy is structured, and this is actually it's kind of interesting because it's pretty much the opposite of where I came from at 7-Eleven. So 7-Eleven, everything was very, very centralized. We had basically these big monoliths, and the entire data org lived in IT. At Chewy, it's very decentralized, and so just by that nature, since pretty much every vertical has a data team, has its own analytics team, a lot of them have their own data science teams, you're going to move very, very fast. And the kind of central IT function, I don't know if we could call it ML ops, but at least data ops, they're there to make sure that that we can move and work very, very quickly and support the business. So in terms of ML ops, I mean, I've got my own opinions about ML flow and DVC and a lot of the tools out there, but I would say that probably the most enabling or disabling thing with ML ops is going to be how you're structured organizationally, and whether or not you have the right resources in place to have roles that just purely support your developers or data engineers or data scientists.
Any other questions? Okay, I think we'll give you 7 minutes back on your day. So thank you very much. Let's give Justin a hand.